In this session, we are going to discuss about the input buffering, specifications of token and recognition of token. Actually, the input buffer is used to hold the input strings. So what is given for the lexical analyzer for the token generation, that is stored in the temporary buffer, that is an input buffer. So it looks one or more characters behind the next lexemes before we can be sure we have the right lexemes. So actually when we have to show the right lexemes, the lot of sequence of the characters are waiting in the input buffer. So where the input buffer is actually divided into n by 2 subposition. So consider the buffer length is n, means each subposition length is n by 2. So where the sentinel characters is used to define the end of the particular string and the input processing. The sentinel character is in CEOF, and it also has a 2 pointer, the input that is in beginning pointer and the forward pointer. So what are the characters available between that input pointer and forward pointers is called as a lexeme. So when that lexeme is matched with the pattern, it is called, and the lexical analyzer give the corresponding tokens for the lexemes. So between these 2 pointers, that is beginning pointer and the forward pointer, for each read the forward pointer to be moved the next character by characters. When it encounter a corresponding pattern, it stop the movement. So the sentinel is used to indicate the end of the buffer. So here there are 2 buffers already. We know there's a left and right buffers. When end of the first buffer is indicated by the EOF, in that time the right side buffer to be filled. So next, the specification of token. So in the specifications we are going to see about the some terms like that, the symbols. What are the symbols? That's in alphabets and strings, like, and languages. So what is in symbols? So symbol means the set of characters, okay, that's called as identifier, and the set of alphabets is in characters, that is an identifiers. It's maybe 0 or 1 or the alphabets A, B up to Z, any alphabets. And what is in string is in collection of characters, and empty string is in epsilon, and the term language denoted by a set of strings over some fixed alphabets. And the regular expressions is defines the set to format tokens, where the regular expressions of for a identifier is defined by a letter followed by a letter or digit, the whole star, where the star is indicated 0 or more. So normally the identifiers may be a single characters or more than one characters, but it must start with the single characters. So the beginning of the identifiers must be a characters, not a digit. So but it may be a 1 or more than. So that can be indicated by that star, 0 or more. Then that languages for the regular expressions is denoted by the L of R. The order of evaluate regular expressions. So actually the evaluations is defined by the unary operator star. It has the highest precedence. Almost it has the left associative. So the concatenations with the second highest precedence and the left associative. Then R symbols is in slowest precedence. It's also left associative. These are the operators which are involved between the regular expressions. Next, the grammar. So the grammar is used to find the token. So where how to express the patterns using a regular expressions. So the regular expressions is expressed by the pattern by using the set of definitions or the rules. So the definitions or the set of rules is called as a grammar. So here the example is the statement of there's a conditional statement, there's an if statement is must start with the if and expression then statements. There's an if statement, or the statement may be a if then else statement, or the epsilon, so that can be defined by some rules. So there's a grammar for identifying the token. Thank you.